Hi, I'm Dan Duran. Welcome to Discoveries This Week. Turns out that putting the toilet seat down isn't only for the ladies' benefit.
This is a good example of something which, as far as I know, has not been studied mathematically in any great detail. It's a toilet.
Yeah.
And if you want to follow where the droplets of water go that make up the entire, bulk of water inside here, the easiest thing to do is to tag them with something. In this case, it's a little bit of colored dye. This is this reddish brown stuff. If we turn out the lights for a second, you'll be able to see the whole thing glowing. Okay.
Oh yeah, and it's glowing green because of that red dye?
That's right. This is an ultraviolet light. Okay, so this is a black light, if you like. And wherever the water is absorbed up this dye, you can see it's this nice green color. And we're going to use this as a tracer for the little drops of water when we flush the toilet.
Okay,
so
well let's
flush
go.
The toilet and see where the drops go. And we've done this a couple of times, and you can see where where the droplets have turned up.
So all those little spots.
There's splodges, all this stuff, all these disgusting things. These are all splodges of water that have come out of the toilet.
Okay, well that's on the seat. I guess you kind of expect that.
You kind of expect that. Perhaps what's surprising is the amount that actually makes it quite a ways off. Let's check out the wall. You see these great splodges? There's a bright one, there's a bright one.
That's a lot. That's quite far away, too.
Droplets of water that have made it out of the toilet. They go a very disturbingly long way. Okay, this is pretty disgusting. And this,
wow, I don't think anybody realizes just how far the flush can carry.
No, it depends toilet to toilet, but in general, I think this is a pretty serious health risk. And this is a very, very good reason, if anybody needs one, to put the lid down on the toilet, to cap the spray to stop it from going out at some long distance. The second
you got to do it quickly if you're going to. Put it down. Oh, I get it.
You
put down the lid, then flush.
Yeah. It's lid down, then flush. I know it's so tricky.
Now, what about the public health message?
Well, first of all, you've got to expect you're spraying a lot of germs around. So the first message is, as frustrating as it is for some people to remember, put the lid down.
Right.
Put the lid down. The drops go a long, long, long ways, and it's pretty disgusting. Second, no matter what, wash your hands. These drops fly about, and this is not the only thing in a washroom where...
No, and the fact that you showed so much of it on the wall, it'd be quite natural to put your hand on the wall, maybe, just inadvertently.
Yeah, or
you have it on your hand.
You're touching things, you're moving around. You carry a lot of germs around. In the flu season, you're always told wash your hands, which is a very good idea to try to slow down the spread of viruses. But this is very good proof that that things do move around and they do stick to things, and you can wind up picking them up. And again, when you come out of a washroom, look, who knows what anybody's got, especially places like airports where people have come in with God knows what sort of disease.
So it all starts with the physics, though.
All starts with the physics, and again, it's a very difficult problem. We've got almost no way to figure out where that would go from first principles other than just tagging the drops with something and seeing where they go.
Thanks, John.
Very welcome.
John Swain, physicist at Northeastern University in Boston.